Assalamu alaikum. My name is Habibullah 2020 is 79. Today we are discussing lab number 10 of digital signal processing, and lab number 10 is about frequency sampling design method. So moving towards uh, lab objective, the lab objective implementation of FIR filter using frequency sampling method. Now without wasting time, we going to see the task. So that's the task 1 of lab 10. Example 7.13. There are three parts of example: A, B, C. In A part, design a linear phase low pass FIR filter with 25 coefficient using the frequency sampling method. Let a cutoff frequency be 2000 hertz and assume the sampling frequency of 8000 hertz. The second part is plot the magnitude and phase frequency response, and the third one is list FIR filter coefficient. So going to MATLAB for run this task. So in the MATLAB, first we define a filter specification: cutoff frequency 2000, sampling frequency 8000, polarized cutoff frequency, and then the frequency sampling method. Then plot magnitude response, then plot the phase response, and plot the phase response. Then compute FIR filter coefficient, and then print FIR filter coefficient. Now going to run this task. So this was the magnitude response, and this was the phase response. Now moving towards task 2. In task 2 there are also three parts: part A, part B, part C. In task 2 says that in part A, design a linear phase bandpass filter FIR filter with 25 coefficient using a frequency sampling method. Let the lower and upper cutoff frequencies be 100 and 3000 respectively, and assume the sampling frequency of 8000 Hz. Part B lists the FIR filter coefficient, and the third one is plot the frequency response. So going to MATLAB. So first define the filter specification: lower cutoff frequency and the upper cutoff frequency, which was given in the lab manual. Sampling frequency also given in the lab manual. Then normalize the lower cutoff frequency, normalize the upper cutoff frequency, and then frequency sampling method. Using frequency sampling method, then plot the magnitude response and plot the phase response. Then compute the FIR filter coefficient and print the FIR filter coefficient. So that's the output of this task. Now moving towards task 3. In task 3 there are few parts. The first one, determine the transfer function, and the 3, tap FIR low pass filter which with a cutoff frequency of 150 Hz and a sampling rate is 1000 Hz using the frequency sampling method. So this was the cutoff frequency 150 and sampling frequency 1000. Then calculate the normalized cutoff frequency, then frequency sampling method, then convert the convert transfer function, then magnitude define magnitude response, then phase response, then plot the magnitude response, then plot phase response, then compute the FIR filter coefficient, then list the first three FIR filter coefficient, and this was the output of this uh, source code. So moving towards the other part, determine transfer function for a 3 FIR filter, 3 FIR high pass filter with a cutoff frequency of 250 Hz and a sampling rate is sampling rate of 1000 Hz using frequency sampling method. So there's the cutoff frequency 250 and a sampling frequency 1000 Hz, and calculate the normalized cutoff frequency, then frequency sampling method. Using frequency sampling method, then convert the transfer function, then magnitude response, then phase response, then plot the magnitude response, and then plot the phase response. So this was the output, this magnitude response and the phase response. Now moving towards next task. The third one is to determine the transfer function for a 5 FIR a low pass filter with a cutoff frequency of 2000 Hz and the sampling rate 8000 Hz using the frequency sampling method. So this is the MATLAB code. Cutoff frequency 2000, the sampling frequency is 8000. Then calculate the normalized cutoff frequency. Then frequency sampling method. Then convert to transfer function. Then magnitude. Then compute the magnitude response. Then phase response. Then plot the magnitude response. And as a result, we get an output like this: magnitude response, and then phase response. Now moving towards next task. Uh, Determine the transfer function for a 5-step FIR high-pass filter with cutoff frequency of 3000 Hz and sampling frequency of 8000 Hz using frequency sampling method. Moving toward the source code. So this was the cutoff frequency 3000 and the sampling frequency 8000. Then calculate the normalized cutoff frequency, then frequency sampling method, then convert that into transfer function, then define the magnitude response, then phase response, then plot the magnitude response, and plot the phase response. As a result, we get an output like this: the magnitude response and the phase response. Now moving toward the last task of this lab. Given the following specification. The first one is 7-step FIR band pass filter, then the second lower cutoff frequency of 150 Hz and 1500 Hz, and the upper cutoff frequency of 3000 Hz. Uh, the third one is a sampling rate of 8000 Hz. The frequency sampling method. Determine the transfer function. So the lower cutoff frequency is 1500 and the upper cutoff frequency is 3000 Hz. The sampling frequency rate is 8000 and then calculate the normalized cutoff frequency, normalized lower cutoff, and then normalized upper cutoff frequencies with sampling frequencies. Then frequency sampling method, using frequency sampling method, then convert to transfer function, then magnitude response, then phase response, then plot the magnitude response and plot the phase response. As a result, we get an output like this: the magnitude response and the phase response. So this is all about lab number 10. Thank you.